This is the Chapter 9 lecture outline video. Even though Chapter 9 is split into 2 different days on the schedule, this PowerPoint slide show is relatively short, so I'm just going to do it in one video. Alright, so this chapter is all about volcanoes, so it should be pretty interesting. So the first thing we're going to talk about are some of the factors that determine the violence of a volcanic eruption. So it's all about the magma. Alright, so it depends on what the magma is composed of, how hot it is, so its temperature, and then what's actually dissolved within the magma. You can think of magma like a liquid that can have substances dissolved into it. So depending on what's in the magma, that's really going to affect the violence of the eruption. All right, so the big thing is the viscosity. So if you want to think about viscosity, it's how thick it is. It's a measure of a material's resistance to flow. So there's many factors that affect this viscosity, and obviously the temperature. So if you think of maybe maple syrup, if you were to heat up maple syrup, it would get rather slippery than if it was at room temperature. So magma is kind of the same thing. Hotter magmas will become less viscous. So it easily flows if the temperature is very high. Also, it depends on what the magma is composed of. So if it has one specific type of rock, let's say basalt, it will have a low silica content, so it'll be more fluid. It'll be less viscous, as opposed to if it had rhyolite inside of it, dissolved within the actual magma, it will have a high viscosity. It'll flow a little slower. Also, the dissolved gases. For the most part, it's essentially water vapor that's dissolved inside of the magma, but sometimes it could also be carbon dioxide. So it could end up making part of the magma when it erupts slightly acidic, which is obviously pretty dangerous. And also the gases expand as it nears the surface of the Earth because it'll start cooling down at that point, and then it'll turn back. It'll go from water vapor into water or carbon dioxide gas into a more volatile substance once it mixes with that water vapor. Just a little bit more about dissolved gases, and this actually provides the force to actually move the lava. It's the expansion of these dissolved gases once the magma actually reaches the surface of the Earth. So viscous magma produces more of a violent eruption. So the more thick the magma, the more violent the eruption is once it actually reaches the surface. All right, so some materials that are associated with volcanic eruptions. Obviously, we have lava flows, and the basaltic lavas, like I mentioned earlier, are more fluid. So there's two types of lavas I'll mention. This is Pahoho lava. I think that's how you pronounce that. I'm probably wrong on that. And then there's lava. So there's two different types, and I'll have pictures of both. There's also gases associated with it. So 1 to 5% of the magma by weight is usually some kind of gas, and it's mostly water vapor and carbon dioxide. So this is a picture of the one type of lava. So this is lava that flows rather easily, and it has this, it says ropey appearance. So you can see that once it starts to cool in this picture, it kind of looks like there's just a bunch of ropes kind of looped around each other. So that's characteristic of this type of lava. And here's the other type of lava, this lava. You're going to see that it's much slower, and it's more one solid mass that looks actually like it's rather cool on the outside, but you're going to see underneath that black outer surface, it's actually quite hot underneath. All right, so the materials that are extruded from a volcano, we call those materials pyroclastic materials. Pyroclastic just stands for fire fragments. So there's different types of pyroclastic material. There's ash and dust, there's pumice, lapilli, cinders, and then there's particles larger than lapilli called blocks, and then we even have magma bombs. So this is just lava or magma that's ejected out of the volcano. Now, I just want to make the distinction between the words magma and lava. Lava is simply magma that has reached and has spilled over onto the Earth's surface. It's the exact same material. It's just we typically say magma is below the surface, and then once it reaches the surface, it's in the air, we call that lava. But it's essentially the same thing. All right, so the different parts of the volcano. So here are the definitions on this page. I'll just go to the picture and describe them. So typically we have a way for the magma to go from somewhere in the mantle underneath the ground up through the crust and then finally out of the volcano. We call that pipe, the conduit for the magma to flow through. We have at the very top a vent. This is their surface opening that's connected to the conduit magma pipe that comes from underneath the ground, allowing things to be thrown out and ejected into the air. We have the crater. All right, this is the steep wall depression opening at the top of the volcano, at the top of the summit. We have a caldera. This is a summit depression that's greater than 1 kilometer in diameter. We have parasitic cones, and these may develop from fissures on the volcanic's flank. So you can see pictures here. You have right here a parasitic cone, where this is another way for lava to actually reach, or magma to reach the surface and then become lava as it comes down the side of the volcano. All right, there's some other types of volcanoes. One type is called a shield volcano. These are broad, that have a very slight dome. They don't have a very high summit like that previous picture. And these are primarily made out of basaltic lava flows. So these would be very fluid-like lava flows. And these are generally very large in size. And an example would be the Mauna Loa volcano in Hawaii. So the very top of this volcano, we have a caldera, so this very large 1 kilometer in diameter circular opening that magma can come out of. These are generally not explosive type volcanoes, but you could definitely have magma coming from the top of these. Another type is a cinder cone. So cinder cones are actually built from ejected lava fragments. All right, so these have a steep slope angle. So you're going to see in this picture, it's very steep to get to the vented opening of this volcano. These are relatively smaller inside compared to a shield volcano, and they often frequently occur in groups. All right, so the anatomy of this volcano is very similar to the anatomy I mentioned a few slides back. There's a composite cone, or called a stratovolcano. These are more adjacent to the Pacific Ocean. So one example would be Mount Rainier in Washington State. They're very large inside. They have interbedded lavas and pyroclastic, so they're all combined together. And these typically have the most violent type of activity. So when these guys go off, you're going to want to watch out if you're nearby. So there's different volcanic hazards to worry about. So there's Nua ardente. These are produced by composite cones. This is fiery pyroclastic flow made of hot gases infused with ash. And these flow down the sides of a volcano at very fast speed, so sometimes at 125 miles per hour. These flows will come down on the side of the volcano, so you don't want to mess around with this. Then you have lahar, which is volcanic mud flow. So you could just think of like a mudslide, but in this case, it will be due to a volcano. So different hazards. Obviously, the ash is something that could affect the weather in an area, actually. It could produce acid rain, which is kind of a scary thought to think about. Obviously, the lava flows are dangerous. Ash and pyroclastic materials piling up on structures can cause them to fall apart and basically implode on themselves. And obviously, lava flows can cause fires and hazards on roads and basically make travel impassable. Just another picture of this is pyroclastic flow coming down Mount St. Helens in 1980. So this pyroclastic flow that you're seeing is composed of ash and pumice, and these are moving at about 60 miles per hour and have temperatures that are greater than 400 degrees Celsius. So that's about 800 degrees Fahrenheit. So volcanoes are something you don't want to mess around with. They kind of look exciting and look interesting, but they're very dangerous if you're ever near one when it erupts. And this is just an example of like that volcanic mudslide that could occur. And this was an example of a mudslide that occurred due to the volcanic eruption of Mount St. Helens in 1980. Other volcanic landforms, we mentioned calderas. These are that steep wall depression of the summit. And these are formed by the collapse of rock at the top of the summit. And these are very large in size. So one example of a caldera is Crater Lake in Oregon. So this is just a nice pictorial representation about how this actually would form. And there's more information in the chapter that describes in detail how a caldera lake can be formed. Other landforms, fissure eruptions and lava plateaus. So fluid basaltic lava extruded from crustal fractures called fissures. So it is possible to have magma reach the surface of the earth and not be from a volcano. So there are openings that allow the magma to flow to the surface. We would just call those fissures. And there's An example would be in Columbia Plateau, and I believe that's the picture on the bottom right. All right, and just to give you an idea, there are some Columbia River shield domes in the United States, particularly in Yellowstone National Park. So it's just showing you that we do have a few different volcanic sites in the United States, but many of them are dormant. All right, the last landform that I'm going to talk about are volcanic pipes and necks. So again, the pipes are the conduits that allow the magma to flow to the surface. So an example of a volcanic neck that exists today is in Shiprock, New Mexico. So this is actually a remnant of a volcanic neck. What happens is that all of the rock around the summit of the volcano eventually erodes away, and then the thing that's left in its place is the remnant of the actual conduit or pipe that allowed the magma to flow to the surface in the first place. So that's kind of an interesting feature that it can exist from very, very old volcanoes. And just to give you an idea, this is 1,700 feet tall. So these things aren't tiny. These are pretty large. But it's a pretty interesting geographic landform that's left over from a very old volcano. All right, that's the end of the Chapter 9 PowerPoint.